difficulties with the links. Hopefully starting to get people to filter in. Thank you all for joining us today for our March meeting for the ASCE West Michigan branch. A couple housekeeping items. Haley is out. She is on maternity leave, so congrats to her and her family. All is well. So I'll be taking the reins for today. Let's see. And then a quick inquiry, if anyone has some contacts with Calvin, I've been trying to reach out for our May meeting to get the students involved. I've not been able to make contact, so if anyone can let me know, I'd greatly appreciate that. So without further ado, I'll introduce our speakers. Since graduating in 1990 from The Ohio State University with a Bachelor of Science in Mechanical Engineering, Paul Schmitz has held a variety of sales, business development, and sales management roles within the construction and technology industry. Over the last 15 years, Paul's experience has been promoting synthetic building materials in the civil and marine construction industry. Most of those years were spent with CMI, focusing on large-scale engineering projects for environmental remediation, flood prevention, and shoreline protection. In early 2020, Paul transitioned to Tensar International Corporation and is the market manager for public roads, setting the strategic growth plan for this market. He consults with a variety of clientele from contractors and engineers to all levels of government agencies, including extensive experience with federal agencies such as the USACE and the NRCS. James has been working with the construction industry since 1999 and has a bachelor's degree from the University of Toledo. He started at Tensar in 2018 as a regional sales manager for the Great Lakes region. And so I will turn it over to you, gentlemen.
Thanks, James. I'll say a quick, that was a great intro. Appreciate the feedback, and thanks for inviting us in today. This is going to be like our James said, probably 45-minute to 50-minute discussion. We want to introduce the topic of geosynthetics, specifically geogrids. We're going to talk mostly on, roadway applications. If you're not familiar with Tensar, we're one of the innovators, founders of the, geogrid market, and they're not used just for roads. We're going to focus roads today, but other applications like rail, marine, walls and slopes, etc. So some of you may have used them before, some may have no experience. So hopefully this is a kind of an entry-level course with a touch of James is going to go through a lot of content here, so we definitely can dig further in future, one-on-one meetings or smaller group sessions. So, and lastly, if you have any questions, you can utilize the chat feature. Just type your questions in, and I'll relay them over to James, and then we'll also make sure you get electronic PDH certificates at the end of the session, though. So with that, I'll turn it over to our local expert, James Klonowski.
Thanks, Paul and James, the other James. Yes, let me skip through this. And because of the time constraints here, I may go through some of these slides very quickly, but the presentation, it's kind of wide or broad. It's general in some ways, but it gives a real good idea of what geogrid and geosynthetics can do for your roadway sections. Real quick, my button isn't working. Man, we're having all kinds of problems here today. There we go. Just a real quick an agenda. We just want to increase your awareness and knowledge of Tensar geogrids specifically in any engineering and construction applications. The two main ones that we're going to go over are subgrade stabilization and pavement optimization, so either paved or unpaved surfaces. I've got a few slides on some of the testing that we do. We're pretty much the only geogrid company that puts a lot into R&D and testing. I mean, we stand by our product because of all the testing that we've done, and I have a couple snippets of that, and then just some cost benefits of using geogrid. So I can't see the chat, but I'm sure Paul will let me know. And if you guys could, I'd like you to answer, what would you consider as important in the pavement design? In this bullets are supposed to pop up as I hit the button, but so you can see the bottom there: cost, life, durability, and easy construction. But if you could, in the chat box, just put in what you think is important when designing a pavement. And then either in a separate one or on the same one, just what do you think your clients think is important when you're designing a pavement? You know, is it cost? Is it solely cost? I know that's huge on everyone's mind now. Is it life expectancy or durability? I mean, I know, you know, when money's not an object, that's certainly, you know, easy to obtain. Well, it's easy to obtain even when you don't have the money if you follow the presentation here. And then ease of construction. I mean, those are only three. If you have others, I don't know if we're going to get to talk about them here today, but we would definitely like your feedback on what you think is important. Paul, is there anything popping up?
Looks like life cycle costs has 3 votes, and all of the above has 2 votes. So
okay,
life
well,
cycle's winning.
Okay. Well, the easy answer is the Tensar triax can help with all 3. You know, the geogrids, they save money in the short term and in the long term. In the short term, by using our geogrid, you mechanically stabilize that aggregate layer. But what we can do is reduce that aggregate section when you're talking about unpaved roads. And in paved roads, not only can we reduce your aggregate section, but we can even take asphalt. Asphalt out. It definitely improves your, you know, your performance in your roadway subgrade, and that's where most of pavement failures, they don't come from top down; it's bottom up. So when you're building on a poor subgrade, and you don't address it, you know, at the beginning, that's when your roads tend to fail down the road. And then it involves minimal labor. We've got some videos you can see. You know, it's not hard to install our product. It really just, you set it down and you kick it down the road. So real quick, I kept this slide in, maybe not so much for this group, but for other groups that I've given this presentation to. I always hear it when I'm out in the field. Hey, you sell that fabric? Well, no, we don't sell fabric. We sell geogrids. But I wanted to go over just real quickly what the difference between the two are. So geotextiles or fabrics, you know, those are for separation and filtration. You get some minor reinforcement with your woven, but not your non-woven. That's solely for separation or filtration. And then at the bottom here, you've got your geogrids. I mean, these are made to stabilize your aggregate layer. And then you get some minor separation. You know, if you use the proper aggregate, you know, a 21 AA would be one. You'll get some separation benefits by using that aggregate with the geogrid. Real quick, I kept this in here. You know, the manufacturing process at Tensar, you know, we've been told to take these out, but our product it's extruded. It's a single layer process. So, I mean, it's all one piece. So there's no joints or junctions that are glued together, so they're not weak. It's all extruded and it's one piece. That's important when you're looking at geogrids, especially because typically our competition, their weak point is at the joints where they adheres 2 pieces together. All right, so quickly we'll go through the mechanisms of geogrid. Aggregate confinement, improved bearing capacity, and tension membrane. Now these are all supposed to act together to make your stone perform better. And this comes from the Army Corps of Engineers. So aggregate confinement. Our triax geogrid, it's really designed for maximum interlock with the aggregate. And if you see the picture there with the stones with the geogrid, what really makes that lock together is the strike through you get with the stone, you know, interacting with the geogrid. And it just stabilizes that base layer, but it's, you know, the strike through is very important. You want real angular stone, you know, to have places to lock onto. The aperture size is matched with the aggregate size. We have 3 sizes of apertures. A small is our 1.3 inch. We've got a 1.6 inch opening, and then a 2.24 for our larger stone. With improved bearing capacity, or the snowshoe effect, I mean, this seems a pretty simple idea, but because of the design of our grid, as opposed to a biaxial grid, which we'll see in a minute, it really does disperse the weight out in all directions, which makes it perform better than most of our, or all of our competition. Second slide on the bearing capacity. This is we're looking at a biaxial geogrid versus a triaxial geogrid. This is a polar chart here, you know, with these concentric circles going out, getting more stiff. When we're talking geogrids, we're usually looking at low strain stiffness. You can see here with the biaxial geogrid, you can see it's stiffest along the ribs, which would make sense. When you go over to the other side with the triax, it's almost a circle in there. Again, because with the hexagon or the 6 triangles together, it's dispersing that weight equally in all directions, and it just makes it perform better. The third was the tension membrane. This really applies to geotextiles. You know, when using a geotextile or a fabric, to get any kind of stabilization out of it, you know, it needs to be tensioned, kind of like a hammock. So with the geotextile, you're not getting much stabilization. It has to fail almost before you actually get any stabilization out of it. So that one wasn't, you know, that's more for the geotextile than the geogrid. But those are the three that the Army Corps came up with for the geogrid. Real quick, again, I just mentioned it, but these are the two types of geogrids we're currently looking at: your biaxial geogrid and your triaxial geogrid. So when I'm talking about aperture, it's the opening size. You got your ribs, and then the junctions or the nodes. And in the triax, you know, we've beefed up all of those. You know, we've got a high aspect rib ratio. It's hard to see in this picture, but it's a little bit easier in some to come. The nodes or junctions have been supported. So the triax is very superior to a biaxial geogrid. And one thing that I'd like to note, that index properties do not indicate performance. And we can show you that by the next two slides. This is the Giroud-Hahn design theory. I'm not going to go through it. To be honest, I'm not sure if I could, even if I really wanted to, but we're searching for H, or your aggregate base thickness, in here. And if you look close enough, you'll notice the one thing that's not on there is tensile strength. A lot of BX specs come out solely on tensile strength, and that's at one point that's all Tensar sold as well, and so we were probably guilty of pushing that as much as anybody else. But tensile strength is not indicative of performance when it comes to a geogrid. For this Giroud-Hahn, this is for an unpaved. This is the design theory used for unpaved. When we're talking about a paved surface, or AASHTO 93, it's the same thing. You know, there's nowhere in this equation is there a tensile strength for a grid. So, you know, when grid came out with biaxial, it was an easy thing to look at and say, all right, this is the tensile strength of this, and that's, you know, we're going to call that out in our spec. But it's not very indicative of performance.
James, we had a question about what happens to the waste product from the manufacturing process, you know, when we're punching and drawing the grids.
Yeah, we capture and recycle all of our waste,
Okay.
and reuse it. Was that?
Yeah, I think that
Okay.
answers it.
Well, we capture it. It's been a while. So we've got a lot kind of stacked up over there. But yeah, we use it all. We recycle it and reuse it. So why BX or why TX versus BX? I started on this a few minutes ago. You can look at the top, the junction strength. This is very important because, I mean, the weakest spot on most geogrids is going to be the junction. And on our triax, we really did beef up that joint or that junction. Another thing that's very important is the rib profile. If you look under the BX, those look flat. And that's not just the picture, they are flat. With the rib profile for the triax, when we were designing it, we took that biaxial rib and basically just turned it on its side. But there's a lot more surface area for the stone to grab onto, which is very, it's very important. That high aspect rib ratio adds a lot to the performance of any geogrid. And then the radial stiffness or bearing capacity down at the bottom. On my left, as you can see with the BX, it's strongest around the ribs and the joints, as opposed to the triax, which is really, it gives its strength in all different directions. All right, so we're going to go through subgrade stabilization. Any unpaved surface that you're looking for, heavy duty construction access roads, wind farms, county roads, anywhere that you're not paving. I mean, this is our bread and butter right here, soft soils. It's an everyday problem. I'm sure you guys have all seen it just as much or more than I have. But this is what Tensar can solve for you with our grids. Subgrades improvement, your typical solution. So if you're in that last picture and you're out on site, most projects or all projects, you're gonna have to do a proof roll to see if your subgrade's competent. So, like that last picture in this case here, it's not. So, if this is your case, what are you going to do here? On a lot of jobs, most people just say, oh, well, we're going to undercut all that poor soil and we're going to fill it with some aggregate and we'll be fine. With the Tensar, though, in that same situation, you can see we excavated, but it's half. In the first situation, you were digging down 2 feet. With Tensar triax, you reduce your aggregate section up to 60%. And in some cases, you wouldn't have even had to undercut anything. If the subgrade was a certain CBR, we could roll the grid out right on grade and go from there. But the performance of the triax, again, it can reduce your sections in half or more. I apologize. It seems like I'm going through this quick, but I am. So let's look at some of the costs or industry costs. The example here, if you looked next to the unreinforced, we've got excavation at $5 a cubic yard. And these prices, whether they're low or high, it isn't going to have a huge effect on the outcomes here. But just know that the higher those prices are, the better the grid actually looks. So if you're looking and saying, 21 AA, $18 a ton, that's not even close. It's probably not right now, but again, the higher that number is, the better the grid would look. So, but in this situation, we've got a section that we've designed to, and I guess in the end, it doesn't matter what it is, but it came out to 24 inches of aggregate over a subgrade of a 1.3 CBR. 1.3 CBR is pretty low, so I'm not surprised that that there's 24 inches of aggregate. Well, let's go on the next side of that. What would happen if we put a woven fabric in there? Again, all the original costs are the same. Unreinforced, it came out to $24.88 to build that section or that system. With the fabric, and these are average prices, we put in $2.50. So it did take a couple dollars out as compared to the unreinforced section, coming in at $21. By using a biaxial geogrid, which was a little bit less, you can see, but it took your price all the way down to $14. And look how your aggregate section has been reduced. Your original, you started at 24. You took out 6 inches with the woven fabric, and you can take out half with just the biaxial geogrid. But then in the last section, you can see with our triaxial TX160, the system price is $12.74. Now, the product itself costs $4.50. That's actually that's including installation. But it reduced your aggregate all the way down to 8 inches on the same CBR, and it'll give you the same easel count or life expectancy, whatever you would design that to. That's what we're basing these numbers off of to get to that same base level. But we get a lot of sticker shock sometimes when we talk to people about our higher end products. You can see in this example here, $2.50 and $2 for the woven and biaxial. Ours is double that. But you can see, because it takes out so much aggregate, the overall price of your section has gone down. Now here's one of just all Tensar solutions. Actually, it looks like the stone went to $20, but the excavation $5 cubic yard. And you can see it's similar to the last slide. Even with your biaxial geogrid in there, $15.67 with 12 inches of aggregate. We make a triax that costs the exact same as a biaxial geogrid, but it actually gives you 2 inches better of performance. So we can take 2 inches out just by using another product that's the same price. So you can see that one came in at $13.39. When you start getting into our higher end grids, the third one over, our Triax TX5, that went down $1, and it also reduced another 2 inches of aggregate. The farthest one on the right, our TX7, that's at present our highest performing grade at $5. But look at the overall cost. Even though the grid itself costs $5, your aggregate cost went way down. So the overall cost, we're trying to look at these as system costs, not just product costs, because when someone gets that $5 square yard price, that's what not everyone can get past that. But when you look at what it's taking out of the project, being aggregate or HMA or labor or excavation, the overall cost using a higher end grid is almost always the lowest. Real quick, just I guess to go over again what I just spoke about. By using the Tensar Triax, you can reduce your aggregate sections or requirements up to 60%. Again, that's going to reduce your labor and your equipment needs. And it's going to reduce the frequency of maintenance because you're stabilizing your aggregate base, your aggregate layer. It's just going to push your frequency of maintenance down the road because it's stabilized and it's not going to fail. And we've got reports that, if we can get into reports and things that we can show, with schedules for that. Accelerating the gravel road construction. There's just a lot of different benefits for this, for the Triax. Sorry.
James, we got a question, maybe a tough one to answer, but what is the expected life of a geogrid? How would we answer that one?
Yeah, it's a tough one to answer. I will say this: we just pulled one out of a project that was in for, I think, 26 years, and it looked like we had just installed it. We actually took a section of it and we have it hanging in our R&D department, and they're doing more tests on it now. They said that was almost 30 years old. Paul, I'll have to get back to him on that. I don't have a set date, that they last 30 or 40 years.
Yeah, I don't think
but I'll get back to them on that.
I think they're assumed to last, quite a long time since they're buried and not exposed to UV, et cetera.
Right. Oh man, I just passed my video here. I do want to show this. It's kind of loud. This is one of my favorite videos. Usually I see, let's guess where there's no geo. Right there, that's where the geogrid ended. But I mean, that's just an example. The subgrade underneath that whole section before was the exact same. You can see how much just putting the geogrid in really added to the performance of that. I mean, that dump truck was, the axle deep when there was no geogrid underneath.
James, how heavy was that? Do you know?
It's geez, oh Pete, 50 to 70,000 pounds. I don't know.
Right.
To be honest with you, I couldn't tell if it was loaded or not. And you guys have a lot of specific questions. I can look it up for you. I'm not 100% sure. Well, let's go back. Can we get a model number on there? I'm looking under, like it's actually going to change. It was kind of hard to itself.
I think your audio goes out when you're on video, when you're playing a video. We'll take that as a side note, try to find out the weight of that.
Okay. Yeah, that's what I was saying. We can find out. I mean, with that video, again, you couldn't really tell if it was loaded. But we'll definitely get back to you on that. But we're going to go over some pavement optimization. I keep these slides in because they're important, I guess, to show. But anywhere that you've got a paved area, roads, airports, any project that you're doing, parking lots, we can help you out in all of these. So industry solutions. On the left here, you've got your unreinforced. Again, no geogrid, no nothing. You've got your 3-inch wearing course, a 6-inch binder, 14 inches of aggregate, and then your soil. This was what that we were designing to. So again, you got your woven fabric. It did take out 2 inches of aggregate. You went from 14 inches of aggregate to 12 just by using a woven fabric. But let's look at our lowest end biaxial geogrid under that same conditions. It reduced your aggregate section from 14 to 10. So even by using an old kind of out of date technology grid, it's still, it works. We didn't sell it for a long time because it didn't work. We had just come up with something new and better. If you look at the last section there with the triaxial geogrid, your original section was 14 and we took it all the way down to 8 with the aggregate section. And I listed this as industry solutions because this is what, a lot of non-Tensar people would have done in this situation. But had you actually gotten someone from Tensar involved, we could have helped you with this. Not just taking out your aggregate, but actually taking out some asphalt, some HMA. So here's another example that's up on the top right. You've got your costs. Again, $5 for excavation, $80 a ton for wearing, $70 for leveling, and $18 for your aggregate. And the TX5 geogrid at $350. That actually includes installation. So back to the example, unstabilized, 4 inches of HMA, over 10 inches of aggregate. Now that came out to 117,000 easels, or a structural number of 3.08, and it's $28.12 a square yard. Now, there's 3 different ways that Tensar will look at this. We can say, You want the highest performance you can get. Money's no object, and I can hear the laughs even through the mute. But some people actually do like this. A lot of private customers, if they're gonna have to own that thing, own that road or pavement section, then they're gonna, they want it to last. So by not taking anything out, just adding a geogrid underneath the original section, you can see what it did to the easels. What's that? It's like 6 times the easel count. It increased structural number, but it also increased your costs, which is why, it's only people that have extra money and they're looking maybe down the road to less maintenance costs to offset some of that. But we call this the performance option. No reduction in anything, just put the grid under, and this is what you get. The other thing we can do is do a cost neutral option. You can see in this case, we took a 1/2 inch of asphalt out and a full inch of aggregate. What we're doing here is we just want the cost to be the same. So as long as we don't go under the original easel count or structural number, and we can get the cost as close as we can to the original cost, that's what we're looking for here. And in this case, you can see, we took a 1/2 inch of asphalt out and an inch of aggregate. And even in the original is $28, our section here is $27.64. It's a little bit less, but we're going to call that even. But even if it was straight even, look at the easel count. You're still getting about 3 times more, more easels out of your section, your road section, because of putting the geogrid in there and you're stabilizing that aggregate base. The last one is the value option. It's in this case here, we took a full inch out of the HMA. What did we take? 2.5 inches of aggregate out. In this case, we just need to make sure again that the easels stay the same or don't go below what your original design was, to get, take as much out as we can and not go under what you would design the road for. And in this case, you can see we went for your original section was $28.12. With the value option here, you're looking at $24.44. That's almost $4. All right, $3.50 less per square yard. So you can see where that adds up. And these aren't the only options we can do. We can tailor this really. If you've got a project and you want to get a hold of me or Paul or one of our other engineers, we can work through all these with you. But as you can see, it's in the numbers here again, you can plug any number in there and it's going to come out this way. The higher these numbers are as far as cost, the better the grid actually looks.
Hey, James, can you keep that slide up? We had a question about if we took a standard pavement section but added geogrid, is there any data to show how much that would extend the life of the pavement? And I think the scenarios, the 2 diagrams on the left there, just the unstabilized and just adding grid, like James said, it looks between 5 and 6 times the easel value for the same pavement design, just adding grid. So I don't know. Does that answer your question, Joshua?
Yeah, and thanks for asking it. And this slide's really helpful. It's kind of based on a previous project that I had where I think, James, you actually gave me some options, and I was looking at it with some engineers. Even the cost neutral option where you're bringing it down to what the design cost was, but you're getting almost 3 times the performance out of the pavement. But in the end, there was kind of still a hesitancy to reduce the pavement section. And then in the end opted for kind of the standard pavement with just asphalt and aggregate. So it's kind of just a statement where, like, I think this makes sense to me, but I think there's still some hesitancy to, especially going to a 3-inch and 7.5-inch aggregate. I think there's some hesitancy from more traditional pavement design, just thinking that, maybe that 10-inch aggregate without the geogrid will still perform better. So any thoughts on that or response to that?
You're exactly right. There is a hesitancy, especially on the public side of the jobs to take any asphalt out. We've done it for private projects for quite a while. The good news is though, and I've got some slides in later, MDOT is getting on board with this. We did some test sections last year. We've got 2 more test sections this year. And they've also got, well, it's maybe stealing some thunder, but there's a project out now that, it came out, it was let from ODOT that actually has 2 optimized sections that they're putting out. It was a design build, but they had the original section and then they had 2 optimized sections that they put out, and they were just going to let the contractor decide which one he wanted to do. And I talk about that a little bit more later, but yes, it is hard, like I said, especially on the public side, to get people to reduce their aggregate sections. But again, I mean, we've got a brief couple slides of showing the testing, but we've got all kinds of testing and case studies and, studies from different universities that show that that these work and that they will hold up. I don't know if that answered your question or
Yeah,
not. Okay. And actually,
great.
there's a project out right now. It's I think I briefly mentioned it at the beginning of the presentation. The city of, what did I say? Kirkwood. James, help me out. What did I say at the beginning?
You say Kentwood?
Kentwood. Thank you. Wow.
You see the comment where Timothy said, I have used GeoGrid on 3 projects in Kentwood on public projects, and they were holding up very well. Great value to the city. So. Okay. Well, then maybe I need to get me that guy's name, because there's one out now that has TX5, the grid that we're looking at here, in the section. And like I said, if it was you, man, I need to send you a thank you note. Yeah, I mean, the spec really dialed down into that. I mean, they wanted TX5 on this project. It was or equal, but in my mind, there was nothing else that they could have put in there non-tensar wise that would have even come close, because the biaxial grids, they just don't test that high. So yes, mark that person's name down. I want to send them something. I got it. Can I move on? Yep. Good. Okay. Oh man, we've only got like a few more minutes. Uniform subgrade elevation. This was just kind of a design scenario, and I'm sure that people see this a lot, where you've got a heavy duty section and a couple standard sections. One good thing, or one easy thing to fix this with grid. Oops. Oh, also it ends up being a bathtub when it rains when you do this. I'm rushing now, so I'll probably just fall apart. But by putting GeoGrid in there underneath the heavy duty, you can see we were able to put every section at the same depth. So and we increase the easel count of your heavy duty section there. So these are some of the slides I have on testing. We've got full scale testing from the Army Corps. Here's actually one of their results. You can see the top one totally rutted through, even almost down to the subgrade. But you can see on that bottom picture, yeah, there's a little bit of rutting on top, but that's where you want your problems, right? You want to be able to, mill and fill as opposed to a complete redo. But by putting the bottom section there, actually has the grid in. I guess I should have started with that. You can see it really protected the subgrade and kept, any kind of deformation up above it. All right, I'm gonna. James, you can go a little past the time if you want to take an extra 5 minutes. So. Okay.
This is a similar test. It was on a smaller scale. The first one was the Army Corps, and you can see. I guess what I wanted to show with this, look at on the pictures on the right, the rut, and then look just from top to bottom, there's almost no rutting at all on that bottom section that had the triax that, had 10,000 passes as opposed to the 3,000 passes on the first one, the unstabilized, and the difference between the biaxial GeoGrid you know, that just shows the difference between the performance of a biaxial and a triaxial geogrid. And I'll mention it now while we're going through these, because I'm not going to read through all these. We actually have some new products coming out that perform even better. So you keep your eyes and ears open for that. MDOT has seen it because they were looking at doing some test sections with it this year. So again, the last slide and this one, there's so many, and these aren't even close to all of them. And we've got so much testing and research on all of our products. Okay, I put this in here. It was from the New Hampshire DOT, only because it was weather related, and I thought it applied, you know, a lot to our region. So they did a test section up in New Hampshire. You can see there on the bottom right, you know, they had 19 inches of aggregate. I don't think it says how much HMA on there, but we reduced the section down to, I guess, about 11 inches with our TX 160. And this is, they were testing the freeze thaw and, you know, what effect it had on the geogrid. And you can see in here, this is part of the case study, and I can send it all if you'd like. But, you know, the base course with the TX 160, you know, reduced and it held up, you know, better than what the non-reinforced section was. Here is actually a local project. You can see how easy. Can you guys hear me?
Not really with the video.
Okay. So you can see how easy it is to install. Now you have to look at your overlaps. You can see there, it looks like they've got about a 12-inch overlap from one roll to the next, and that's minimum. We always require at least a 12-inch overlap. The softer your subgrade is, the more your overlap is going to be. But I mean, the most overlap we requires is 3 feet, 36 inches. So, but again, didn't go. It's not hard to install. It's very easy to install. Now, after you unroll it, you're going to back dump some aggregate. Just push it. Can you guys hear me now?
There you go.
Oh, good. I like how they have another person up here kind of directing, because you can see that, you know, with the triax, it does wave. Now, this is an older picture. We've actually changed how we make it so it doesn't wave, I guess, if that's what you want to call it, as much. The product we have now, it stays more flat. But again, just push the stone out over. You're going to want to obviously compact it. If your subgrade's really wet, I would say do several static roll passes before you put the vibrator on. The vibrator will just want to draw that moisture water right up. I guess here's another picture. Again, it was the Ypsilanti Library. This must have been a two-layer job, because they've got stone down and then he's pushing stone out over it again. Very easy to cut, you know, to cut around these corners or manholes. A little razor knife. We have a couple like razor hooks that you could use, but any little razor knife cuts through very easy. I don't know if he should be lifting that by himself, but they're heavy, but not overly heavy. Certainly easy for a two-man job. You know, the ends of these pieces do tend to want to recoil. You know, it's just the memory. Just throw down a couple shovelfuls of aggregate to hold those down, and you're good to go. So the important thing is make sure you keep your overlaps where you want them. We get this question a lot. Can you trench through it? Absolutely. There's a picture there. I've got the next slide's a video. so I won't talk about that too much till we get to it. But I mentioned earlier with the right aggregate that you can get separation. You see the bottom picture there. I mean, there's geogrid in there, and I mean, I don't see any soil migrating up through that grid. So, I mean, it looks like it did its job as far as doing any kind of separation. Here's the video. Again, now if you would have put a woven fabric down, you can't trench through it. You know, for you utilities, it would just pull in all that aggregate. But with the geogrid, you know, the teeth on that bucket just go right through it. You can kind of see a little bit of it back there. So you can trench through it. So if you just want to go do the whole thing and then trench through afterwards for some utilities, then you can do that. Okay, so I did get to it. So this was the project I was, I guess, alluding to earlier. It's under MDOT's innovative construction methods. This is what they got it in as. Now, this is a report that we had sent out. You know, it's your original design. I don't know if you guys can see my mouse or my cursor, but there's 3 different or 4 different designs here. One without geogrid and 2 with and 1 concrete. But this is something that we can do for anybody. It's free of cost. I was going to mention it at the end, but people might start falling off. But we have our new product or our new software called SpectraPave. Well, it's not new software, but it's new that in the fact that it's on the cloud now. The interface it's very nice. These are actually older pictures. If you after this, I would, you know, if anything, I'd say get on to SpectraPave and download it. We don't look at what you're doing. We don't even know what you're doing on it. So back to this Mound Road, you can see on the left side there, unstabilized pavement section was 3 over 3.5 over 4.5 over 18. And we came in with our TX7, which again, at current time is our best grid. And we took 4 inches of aggregate out and 1.5 inches of asphalt out. We presented this to the 2 contractors that, you know, that look like they might get the job. And it looks like both of them would certainly go one of these routes. But it'll be interesting. I guess the good news is that really MDOT's, I'm not going to say they're on board because they're not just blanketly specifying these all over, but they're definitely a lot farther along than they were a couple years ago, as far as accepting other sections, especially with taking out asphalt. This might be the first one that they've done it on. In this Mound Road project, they did have a rigid pavement section as well. And we didn't talk about it at all, but there is benefit to putting grid under a rigid pavement. You can see here we didn't reduce any of the concrete, but we did reduce the asphalt. I think the main benefit of putting it under concrete is the settlement between your concrete pads. You know, by putting grid underneath, they'll all settle uniformly as opposed to, you know, differential settlement. So obviously in this case too, we took out the aggregate and the cost was less for this option as well. Okay, I kind of got towards the end. The rest of these are just like questions, myths, and facts, and I can keep going, but in case there's anyone that needs to get off now, Paul, is there any other questions in there?
Yeah, we have 3 other really good questions here. If you want to, we could probably focus on these.
Yeah, I'd rather do that than these myths and facts.
Does cutting the geogrid reduce the integrity of its overall strength?
No. That's can you? Oh man, I got my background on, so you can't really see it. But no, I mean you could shear through all there. Now the ends of these pieces where there's nothing containing it wouldn't give you any support, but it's not gonna give you any less performance. Now if you're trenching out you would want to put GeoGrid back in, but in that case, you'd also want some overlap. But just cutting through it, it doesn't. I don't think it's going to affect anything.
It's just probably a pretty small overall percentage of surface area if you're cutting out one little section.
Yeah,
there's another one.
I mean, I guess there's a lot of different ways we can look at that, but the GeoGrid has to be. I mean, if you took one piece and you cut it down the middle, and there was no overlap, then yes, that middle part would probably fall right through. I mean, so there has to be some overlap on your material. I guess it depends on how you look at that question. I'm not real sure like where they cut it. I mean, if you're just cutting off the end of it and then using the other roll for the rest or in another area, that's perfectly fine. We do that all the time.
Yeah, there's another one. I guess it's probably in relation to the video where they had the curbs. So it says when you talk about overlapping within the pavement, but I see they're using it there against the existing curb. Do you need to install it under the curb if you're doing a full reconstruct? And how does it perform when just placing it up against an existing curb?
Yeah, I would just put it right up against the curb. You don't need to put it under the curb. I guess depending on what your section is, the concrete section for the curb is going to be stronger than what your asphalt section is. So you don't need to put it under the curb as well.
And then the last one was, is there a repair method for GeoGrid when trenching? And how do you get the 1 foot overlap? So you kind of mentioned that you got to put a piece of grid back down in there, right?
Here we go. This was one of my myths and facts is, can you trench through it? So yeah, you would, if this was like your utility trench down here at the bottom there, you would want to put, some grid under there. And there has to be some overlap on the sides, of that top piece there to make sure that grid stays. We do have some section details. I guess this one isn't that great of what to do if you need to trench through and you want to replace the GeoGrid.
Yeah, we can try to share that with the group afterwards. We'll get that over to you,
send out
James.
some of the section details. Yeah.
Any other questions from the group?
I grabbed this off LinkedIn, but I like it. Said there's always going to be someone who can say they can do it cheaper. And that's true, especially in the GeoGrid world. But, a lot of times you get what you pay for. And I think this might be my second to last slide. I don't know if you can see it. That boat says change order, the big one. The little one's like original design or concept. So I don't know. I'm going to leave that one. I'm not going to comment on that one. I don't know who's on. I don't want to get in trouble. So, but that was it. I really thank you guys for listening. Hopefully you got something out of that. I definitely think, if you could get on SpectraPave and look, it's a great software. It's very easy. It's not Tensar's, we designed it, but we designed it using Jarut Han and Ashto 93. It doesn't work just because Tensar says. I mean, we used other people's, design theories for our software. So, but again, thank you all very much. Email me if you have any questions. If you don't have my email, I'll get James to send it out. Or if you have any projects that you want to go over, either Paul or myself could certainly give you some different options with your sections. So thank you very much.
Yeah, thanks everybody. We'll make sure we get certificates out and some follow up on some of the questions as well. So thanks again for everybody's time. Good job, James.
Paul, James, thank you so much. That was fantastic. We'll definitely, I'll coordinate with the both of you after this meeting, and if there's anything else you wanted to include to send out, I'll make sure we get that out to all the members as well as the PDHs for today.
Okay.
But if there's nothing else, I think we can adjourn. Thanks so much. It was fantastic.
Thank you.
Thanks, everybody.
Thanks, James.